welcome back to another lecture. All right, in this one, as promised, we're gonna start finding rules. Okay, we're gonna start making things a lot simpler. First of all, we have this sort of stuff. Okay, so if we have x to the power of n, how do we anti-derive it? Okay, how do we find, is there a rule to this? If you have done enough problems on your own, you would have realized that there is a pattern that it follows. And we're going to find this pattern now. So, same process as before. You increase the power and then divide by that newfound power. And you add your plus c. And that is it. That is your first rule. And maybe it was a bit anticlimactic, but it's there now. Now you don't have to do all that increase, decrease, all of that stuff. You just slap this in. Okay, you go, happy days. All right, we found a rule for this. What do we do when we cannot find a rule, or we're stuck? Like if you have something like this, if you have sin x, and you're trying to integrate this, okay, we're kind of stuck because first of all, there is no function that when you derive you get sine of x. Okay, that is like a simple function, and we can instantly guess, or maybe some of you can, but like it's not entirely obvious, and we're kind of stuck. So there's a process to finding it. It's literally just trial and error to get to the integral. Okay, so for example, we can try this. We can try cos of x, because we know that the derivative of that is negative sine of x. Now that's not quite it, but it's very close. Okay, what we want to do is we want to multiply both sides by -1, which will leave us with sine x. So whatever we get on this side, when we derive it, you get sine x. Okay, so that is what we are saying, and that is what we're looking for as well. So it works perfect. So you get negative d on dx of cos x. Okay, that is sine x. Straightforward. Now we just realized that, well, having a function, all right, differentiating it and then multiplying by -1 is the same as having a function, multiplying it by -1 and then differentiating it. It gives the same result. So this is literally the same as negative cos of x. Okay, so we have found that when you derive negative cos of x, you get sine x. So the integral, or the antiderivative of sine x, is negative cos of x plus c. Plus c is very important, so important to the point where it has its own name. It's called the constant of, can you guess, maybe integration? Yeah, constant of integration. It has its own name. That's quite cool, actually. So yeah, the constant of integration. Okay, we've got that. We know how to find the derivatives. Okay, when we are stuck, we start with something similar, and we go on with life. Okay, let's make it a bit easier this time. What if we have the function e to the x, and we're trying to find the integral of it? We're saying, what function do we derive to get e to the x? Well, it's e to the x. Okay, simple. Okay, so the integral of e to the x e to the x is e to the x plus c. Okay, simple stuff. Now we are going to combat one of the most handy things we had while differentiating. Okay, we had the chain rule, and we are now going to combat it. Okay, so we're going to say that if you have a function like this, okay, when you were trying to differentiate it, you would use the chain rule. This time we're going to try and integrate it, but don't worry, it's not going to be too complicated. Okay, this function is only going to be linear as per the course standard. It's not going to be more than that. Okay, only linear. I'm going to try and find a rule again to integrate it. Okay, so let's go and jump right in. We're going to go with the most basic linear thing we know, which is this. Okay, ax plus b. Okay, and that a can be anything, b can be anything, and that captures every single linear function. Okay. And now when we try to integrate that, we get, well, we don't know it directly, do we? What we do know is, if you have something to the power of n, you can try this, and if it works, it works. You know, for x to the n, it works. And we know that when we try something similar and we don't get the right answer necessarily instantly, we can just modify it a little bit, get some good stuff out of it. So what we're going to do is we are going to say that, okay, we're going to assume for a moment that when you get this, okay, we're going to say that maybe, just maybe, because x to the n has the integral of this, maybe ax plus b has a similar integral. Okay, we're going in with those hopes. We're going to try. And when we differentiate that, we get n plus 1 over n plus 1. They cancel out. And you get ax plus b to the n times a. Already popped the bubble, but because of the chain rule, okay, derivative of outer, derivative of inner, okay, you get this, which is, again, it is quite close, but it's not quite it. Luckily, it's only being multiplied by a constant, so we can just divide both sides by a, and we'll get ax plus b on this side to the power of n, as we need, and on this side we'll get d on dx. Well, the one on a would be outside, but like I said before, when we're looking at the negatives, doesn't matter if you differentiate and then multiply, or multiply and then differentiate, you get the same thing. So we'll just go with this, 1 on a, ax plus b times ax plus b, n plus 1, n plus 1. Okay, so now we know that the integral of this is equal to this, okay? A handy lot of stuff to write, but it's okay. And the plus c, again, very important, 3 marks. And there you have it, okay? We have a rule against the chain rule, okay? All right. And literally, that is kind of the process of integration at this stage, okay? You literally either know a rule or you don't know a rule, okay? If you don't know a rule, you just try and error, and you get there, okay? It only gets complicated to the point where you have to think about what rule you're going to start off with, like what rule you're going to use to get this function here to have something to start off with, and it only gets that complicated. It doesn't get any more complicated than that. And most of the time, it's pretty intuitive what rule to use. So if you have a trigonometric stuff, obviously the thing in here is going to be as a trigonometric function, okay? You're not going to use e to the x if it's just sine x, okay? Inside, and you're trying to find integral with stuff like those, okay? So it's pretty intuitive once you start practicing. You don't get that intuition from birth. It takes practice, and you get there with time, okay? With time and with a lot of practice. So I want you to get right into it and get very, very good at integration, because good chunk of the whole kind of chapter relies on your ability to be able to integrate, and that is kind of it, okay? And you're going to see why the whole chapter rests on that ability in the next lecture, okay? So I'm looking forward to having good students that have practiced this very well in the next lecture. Thank you.